Often, two voltage signals are to be compared and to be distinguished which is stronger. For such situations, a comparator may be a perfect solution. So, it forms the basic building block required for a non-sinusoidal waveform generator, or we can say as a relaxation oscillator. So, op-amp circuit. Op-amp circuit can be used as a comparator circuit. It has got two inputs and one output. The two inputs can be compared with each other, and one of them is out of that one of them can be considered as a reference voltage. So output will be based on which input is higher. See here, output stays in a high voltage when the non-inverting terminal input voltage is greater than the voltage at the inverting terminal, and switches to the lower voltage level, that will say as minus Vsat, when the inverting terminal input voltage is higher than the non-inverting terminal input voltage. So the output will be switching between two voltage levels, plus Vsat or minus Vsat, depending on which input is higher. The non-inverting is higher, plus Vsat. Inverting is higher, it will go to minus Vsat. Now we will discuss about various applications of a comparator circuit. One is a zero crossing detector. It is otherwise it is called as a sine to square wave converter. So this is the circuit of a zero crossing detector. You are two input terminal, non-inverting terminal and inverting terminal. Inverting terminal is connected to ground. The non-inverting terminal you are applying your input signal. So inverting terminal voltage, that is it is grounded, we can say it as 0 volt. So this is taken as the reference voltage because V reference is 0. Non-inverting terminal, it is a sine wave, that is the input signal. So we can say that this comparator is working in non-inverting configuration because your input signal is applied to the non-inverting terminal. Now let's see what is the output. See, suppose you are applying a sine wave. I'll move to the next slide and I'll show you how the output comes. See here, during the positive half cycle, so your input here and we are applying during the positive half cycle. This voltage, as I already told you, V reference is equal to 0. So positive voltage is anyway higher than 0. So during the positive half cycle, if I am going to draw the output, say this is my V out. Positive terminal voltage is higher than the inverting terminal voltage. So it will switch to plus Vsat. Now during the negative half cycle, what will happen? During the negative half cycle, the voltage will be below 0. So this reference voltage is higher. That means negative terminal voltage is higher. It will switch us to minus Vsat. Again next positive cycle the same thing repeats, you will get plus Vsat. Negative high cycles the same thing repeat, we will get minus Vsat. So it is a sine wave to square wave converter. Depending on your positive half cycle, negative half cycle of input, whether it is higher than 0 or lower than 0, according to that your output voltage will switch. So it is detecting the 0. 0 is the reference. Hence the name zero crossing detector. So that is the reason it is called a zero crossing detector. Another application of comparator circuit is a window comparator or a window detector. Sometimes it is required to determine when an unknown signal is between two precise difference thresholds, VUTP and VLTP. So, this determination can be made by a circuit known as window detector or a window comparator circuit. So, it consists of two op amps or two comparator circuit. So, and you have say two voltage level. This comparator circuit, it's marked as VUTP. That will be the reference voltage given to non-inverting terminal. This comparator circuit, the voltage level VLTP, that is known as the reference voltage given to the inverting terminal. And V input, that is the input signal we are applying. And now see here, this is negative inverting voltage you are applying your input. So this is inverting mode comparator. Here plus terminal, that is non-inverting terminal, you are applying your input. So that is a non-inverting comparator. This is nothing but a simple AND gate. Now remember one thing, always VUTP will be higher than VLTP. We want to detect a voltage level between VUTP and VLTP. So for that, this is the circuit we are using. This voltage is lower than this voltage. UTP is higher, upper threshold, and this is lower threshold. Now let's see the operation. How does it operate? See, just consider the first condition. Your V input, that is, assume that first thing you have to remember that VLTP is always lower than VUTP. VUTP is upper threshold voltage and VLTP is lower threshold. So now suppose that your V input VI is less than VLTP. That is the condition. VI is less than VLTP. For your more understanding, I'll just mention everything by a voltage level. Say VUTP is equal to say 5 volt. It is fixed. VLTP is equal to say 1 volt. Sorry, say 2 volt. Now take your VI. Take your VI here as 1 volt. 1 volt is less than 2 volt. Fine. Now see, what is your VUTP? It is 5 volt. This is 1 volt, which is higher. Non-inverting terminal voltage is higher. So the output switches to plus Vsat. So I'll just represent the plus Vsat by a 1. Now see here, this is input is 1 volt, VLTP marked as 2 volt. So 1 volt is lower than 2 volt. So that means VLTP is higher. Negative voltage is higher. So the output here I'll mark it as 0. This is an AND gate. So 1 multiplied by 0, your output will be getting as 0. Now, so if I have drawn the two voltage levels, this is 1, this is 5, this is 0, this is 2. Now just see here, when your input voltage is 1 volt, your output is 0. I'm just going to draw the output here. The output is 0. Now take a voltage Suppose here consider your input as 3 volt. So that means your input is higher than VLTP. Also it is lower than VUTP, isn't it? Because VUTP is 5 volt, this is 3 volt, this is 2 volt. Now see here, 5 volt and 3 volt, EUTP is higher. This is 1. 3 volt and 2 volt, 3 volt is higher. So this is also 1. So the output will be 1. So between 2 to 5, this is the condition. Now take Vi greater than 5 volt. Say that means Vi greater than your VUTP. So say 6 volt Vi. So 6 and 5, 6 is higher, this goes to 0. 6 and 2, 6 is higher, this goes to 1. 1 into 0, 0. So greater than 5 also it is going to be 0. So it is detecting 2 to 5. That means between VLTP and VUTP levels. So that is called a window detector.